Okay, guys, all set. Recording is on. All right. So let me share my screen. Welcome you all in the class and wish you happy new year to everyone. I hope you guys enjoyed a lot during the new year. All okay, guys? Okay, so last session we had a basic discussion about, like, let's suppose you have the very brand new firewall. So how you are going to do the step-by-step configuration and understanding, like taking the console and all. So as we are going to start our module, that is the very first module of today's session, that we are going to discuss about the platform and architecture. So in this module, we are trying to understand, let's suppose I have the Palo Alto firewall and any packet need to be processed through the Palo Alto firewall. Then what is the step-by-step functionality is going to happen inside of the Palo Alto firewall? That we are going to understand in today's session. So for that, we have to understand about the flow logic. That's the module one, from where we are just starting from the scratch. So this is the flow logic. So in this flow logic, we'll try to understand. Let's suppose this is the firewall. Any interface Ethernet 0 by 0, and this is another interface Ethernet 0 by 1. If this packet needs to be transmitted by this particular PC and they want to reach to this PC, so before it is going to deliver, once the packet is going to enter inside of this firewall, then what all processing is going to be happen. So that I'm going to understand in the flow logic. Before I can start, you guys have any questions? Anything you want to discuss with me? Or all good? And for you all in the new
Yeah,
year,
hello, sir.
yes,
Actually, I have one question.
yes,
This is the first class for me. So I just
okay.
want to know that how many classes I have missed and what were the topics which I missed.
Technically, you don't miss it, means you haven't missed anything, but just basic building discussion, right? Let's suppose basic fundamental of the firewall. So we are starting the module one from today. Okay. So everything is going to
Okay.
be covered, right? Whatever even we discussed in the past, that also going to be covered in the future. So we just had a basic,
Okay.
right? So you don't have to worry about anything. So we are going to start from theoretically. That's officially module one. And from here, we are going to start each and everything. Okay.
Okay. Thanks.
Okay. For you all also, what I have done, I just wanted to do training as a next level. So I just onboarded a very brand new firewalls and latest firewall, right? So this latest firewall is 11.0 series of the firewall. So earlier we keep doing a training on 10.0, 9.0, 8.0, but now we are going to learn on the latest one. That's 11.2.3 dot means that's S3. This is software version. So means everything is going to be latest, right? And I'll show you probably nothing is going to much difference throughout this all learning. But yes, you should know like how many software version are available and what are the latest version. So we are on the latest version. And if I go in the software, you can see probably we're not going to get the software. Hi, may I know your name, Geo Broadband, and someone is connected with the iPhone. Please let me your name. I can just rename it. Can you guys just let me your names? Who's joining
Ravi,
the
Ravi, Ravi,
Yeah,
Ravi,
hi, this side Lokendra.
iPhone is Lokendra, right?
Ravi.
Yes.
Okay, iPhone is Ravi and Geo is Lokendra. Let me rename it. Okay, Lokendra
Okay, fine.
and iPhone is Ravi. Okay, thank you so much, Lokendra Ravi, for joining the session. All right, guys. So this is the latest one firewall. So in this latest firewall, we'll explore even what all the feature available in the 10.0, 9.0, and 11.0, 11.2.3. Technically, nothing much difference we have except some kind of the vulnerability has been fixed and some kind of the latest SD-WAN patches has been updated, dynamic update has been updated. Rest everything is going to be same, so you don't have to worry about it. Even interfaces are going to be same, exactly same. Okay, so let's start. And where is my packet flow? Let me open that. This is my FortiGate. Okay. So let's say start with the flow logic, and that is known as the packet flow of the Palo Alto firewall. So let's suppose this is my firewall. And this firewall have the multiple interface. This is the one interface, this is another interface. So this interface is Ethernet 0 by 0. This interface is Ethernet 0 by 1. So again, the same example, let's suppose there is one device. This is one device. This is the PC A. Want to communicate with the server 1. So when the first packet is going to process, means if this device want to send some packet from this PC to this server, then how firewall is going to react on that particular packet, and how much time this firewall is going to take before it going to send out from one interface to another interface. So the first thing you have to understand, the firewall where they receive the packet, means this is the interface where the firewall going to receive the packet, right? This is known as the your ingress interface. That is our receive packet. When the firewall is going to send out the packet or transmit the packet, that is known as the egress interface. Means egress means something I'm going to send out. Ingress means something I'm going to receive. So that's why you can see in this particular packet flow, when we talk about the journey of this particular firewall, means the packet throughout the firewall, we have the one section that is a ingress. We have the another section that is a egress. And before egress, right, and after ingress, we have a lot of boxes available. We have the fast path, we have the slow path, we have the application identification, we have the content inspection. So we have to understand why these all sections are available and what is going to happen once the packet is going to land inside of the firewall. Okay. So in this topology, you can see that, let's suppose this is the firewall, and this firewall basically have this one interface where this device is connected, and this is the internet. So once this packet sends some packet, this means this particular PC sends some packet to this firewall interface, then this firewall, before sending out to the internet, what all action it is going to take. The same thing we have to understand. All right. So I hope you guys understand the agenda of today's class. So let's see that. So in any packet, when it is going to receive by the any computer, they have the multiple information. So let me write it here. So the packet have the multiple informations. Let me put it down. Okay. So we have the source MAC, we have the destination MAC. We have the source IP, we have the destination IP. We have the source port, we have the destination port. Right? We have the applications, we have some additional field, right? And we have the actual data, which is known as the payload, which is known as the content. So these two things are basically layer 2. These two things are basically layer 3. This two things is basically layer 4. This is the application is basically layer 7. And we have some additional field as well. Then finally, we have the content. We have the payload, right? So if I talk about that, why this all information is available in any packet. So to understand that, you have to understand the OSI model or TCP/IP model, right? In this OSI and TCP/IP model, we have the different layer. Like we have the physical layer, we have the data link layer, we have the network layer, we have the application. We have the transport layer. Now we have the session presentation and application layer. If I talk about the OSI model, so that's why in technically TCP/IP, session presentation and the application are going to one layer, right? And then we have the transport layer. So this is your one layer is going to be app layer, right? And then we have the transport layer, and then we have the network layer, and then we have the data link layer, and then we have the physical layer. So your packet is going to belong from the layer 2 information, layer 3 information, layer 4 information, and then layer 7 information. And then data is actually your wiring. So that's why in this particular packet, you have the all layer information, because it's a very important. Okay. It's a very important, guys, because if packet is not going to follow and like blueprint of the OSI or TCP/IP, the packet is never going to transmit it from the one PC to another PC. That's why it's a very important. All right. So in this particular packet, almost every OSI or TCP/IP model level information is available, and every information is very important. So once this packet is going to land to the Palo Alto firewall, the very first step, they are going to extract some information from this particular packet. So what is that information? You can see here, they are going to extract the layer 2 information. They are going to extract the layer 3 information. They are going to extract that layer 4 information. And also they are going to figure out what is the zone and what is the interface associated with that particular packet. Means firewall, basically, when the packet is going to receive on the firewall, let's suppose this is the ingress interface. Interface name is Ethernet 0 by 0, and this is 0 by 1. So packet is this one. In this packet, they have a lot of information. They are going to figure out layer 2 information, layer 3 and layer 4. They are not going to extract the layer say information and the content informations. That is going to be exactly same. They are not going to get out that information. And based on that, because this is going to give you the your like interface information from where the packet is going to become. So they are also figuring out which interface, basically it's the Ethernet 0 by 0 or 0 by 1, or might be some Ethernet 0 by 2, which interface basically receive this packet. And every interface must be associated with a zone. So in Palo Alto Firewall, also zone is going to play a very vital role. In FortiGate, zone have the different use case. ASA zone have different use case, but in Palo Alto, it's a play a very vital role. And without zone, if you are thinking to do the configuration of the any interface of the firewall, it is not possible. Only HA is the only interface where zone is not going to be required. Rest any type of the interface, if you think, they must require the zone. Without zone, it is not possible you can do the configuration. Okay. So zone is going to play a very vital role, guys. So they are going to figure out zone. We'll discuss what is the zone later on. Now, after figuring out these all information, what next? So the next is they will check whether the packet I receive, it's a fragmented packet or like the unfragmented packet. What does mean fragmented, unfragmented? Anyone know that? What is a fragmented? Anyone know about the fragmentation?
It's like the packet size is bigger than the default one, that is the 1500 bytes MTU size. And
Yes.
if in that case, it will break the, like, it will fragment the packet as per the interface compatibility. And according to that, it will send the traffic.
Appreciated, Abhijit. Yeah. So I hope you guys understand. Anyone have another thoughts? Okay. So what Abhijit mentioned, that's absolutely fine. So what happened? Like you have the router, you have the switch, right? They have the default interfaces. Means not default, they have whatever the interfaces they have the by default MTU size. This is the maximum transmission unit, that is a 1500. So let's suppose this is the one packet you're sending that, but its size is might be 3000 as a packet size. So once this interface will receive this packet, it will not able to digest all the packets. So they will, like, this is one packet size. So they will chunk this packet, one packet into two packet. So now they are become the 1500 bytes. And then they will easily like digest the packet and it will process via this link. This link also going to carry the 1500 packet only. This is also going to carry the 1500 packet only. So from here, the packet will like come and reach to the router, and then it is going to reach to the switch and then router. Let's suppose this is the firewall again here connected. So this firewall will receive these two packets, and once they are basically fragmented packet, then firewall will come to know, yes, they are a fragmented packet. So they will do the reassembly, means they will make again a big packet to understand the whole content of the firewall, means the packet. And based on that, they will check what is inside of this particular packet and what action I have to take on this particular packet. Okay. So this is the very first step firewall is going to take after receiving the packet. Then what next? So I'm just clearing the screen, and now let's see, guys. So now this section we understand what is going to be happen once the packet is going to receive by the any firewall interface. The next step, the firewall is going to check the packet which I received, that they are really a valid packet or invalid packet. So they are going to just validate. How this is going to happen? Means any packet, if they have any error, that is always going to be invalid. If there is no error, then it is a valid packet. So if the packet is invalid, then they are going to simply discard that particular packet at the firewall ingress label itself. Means this packet is not going to enter inside of that particular firewall. It will simply discard it. But if there is no error, then it is going to process to next step. So what is the condition of the error? Means how this firewall is going to come to know which packet is basically good, which packet is basically bad. So you have to go down. There are certain things. Okay, you can see there are certain things like we have the mismatch Ethernet type, right? We have the like protocol number 0. We have the ping of death. We have the truncated IP header. We have the land attack. We have the Martin IP address. We have the IP checksum error. So either of a condition is going to meet, the firewall is going to simply discard the packet. So you can see mismatch of the Ethernet header type. So Ethernet header type should be the, we know that Ethernet header type. So we
Which
should,
ping of death?
hello, Rohan.
Yes. What is ping of death?
So I'm coming ping of death. I'll explain one by one everything. Okay.
Okay. Okay.
So if Ethernet header is going to mismatch, truncated IP address means there is 32 bits of the IP. There is 32 bits in the IP headers. So let's suppose there are 28 bit of the IP only. 4 are missing. So that is also going to be discarded. This is also going to be discarded. This is also going to be discarded. IP protocol number should not be 0. In that case, also going to be discarded. TTL should be not be 0. More than like 0. Should be 1, 2, 3, 4. Should be like that. Not should be 0. Then packet is going to be discarded. Now we have the land attack and ping of death. So ping of death and land attack. Land attack, if I talk with, again, it's a kind of the DOS attack. Like layer 4 denial of service. So denial of service. Denial of service. So this is the your land of attack. So anything which is known as a land of attack, that means there are TCP based denial of service is going to be happen. That is your land of attack. Ping of death is, it's again type of the DOS only, but based on the ICMP. So if anything is going to be happen based on the ICMP attack, where our services is going to be disrupted, that is known as a ping of death. Clear? Who was asking? Rohan, it's clear to you?
Yes. Like when is ping will be like what is that like exact definition of ping of death? Like
So you,
when we will like when we can consider that as the ping of death.
so you are okay. You asking this question because you don't know what is a DOS, right? So let me show you. So if you go in the DOS attack, right? So DOS having the various attack. There is a sync flood. This is a TCP attack. Okay. This is the UDP attack. So TCP UDP is the layer 4 attack. Now you can see this is the ICMP attack. So this is basically ICMP based on the ping attack. So this category attack is going to be happen, that is known as the ping of death. So kind of the DOS attack where, let's suppose this is a router, okay? This is your WAN interface, your ISP. This is one of the PC which is belong to the hacker, right? This link have the capacity 10 Mbps, okay? and you are just sending 2-3 Mbps traffic on daily basis, rest are the buffer. But suddenly this PC have sent a lot of ICMP packet on your this destination. Might be 10 million packet or might be 1 billion of the packet. What is going to happen? This entire link is going to be chalked. So this interface will never process any traffic. This is known as the ping of death. Means you are going to send a lot traffic on your any interface, which is just causing to just stop sending any traffic. Clear?
Yeah, now then, so that's mean attacker will continuously send their pings to the destination host. So that will be like
In
so.
form of the ICMP, not TCP, not UDP.
Mhm.
So you can see ping of death attack is type of denial service at attack that involves sending the oversized malformed data packet to the system services or computer to go to the attack to crash, freeze, and destabilize the target. And this is going to form in terms of the ICMP only.
Actually,
Okay.
this attack will be from the single source or multiple sources, like
DOS is
DDoS.
DDoS is also always going to be multiple source, distributed denial of service. DOS is basically from the single source.
Okay.
So this is the definition of the DDoS and DOS. DOS is a distributed denial of service. DOS is denial of service, where it is going to originate from the single source or single application. Okay, all good?
Yes, we shall now clear.
Okay, thank you so much, Rohan. So now we have the Martin IP address. So what is the Martin IP address? So Martin IP address is the IP address which doesn't like exist in the universe. That means the IP address invalid IP address. Let's suppose I am writing this. Do you guys think this is the valid IP address? This is the invalid IP address. So if some device have this kind of the IP address and sending the packet, firewall will simply discard those kind of the packets. If any checksum related error, IP checksum related error, that is also going to be discarded. So anything is going to happen from this range while doing the packet processing. This is always going to discarded by the Palo Alto firewall, and that's why there should be no any kind of the ingress error on any like packet which is received by the Palo Alto firewall. Now, let's suppose we don't have any of this particular any error on this particular firewall. So what is the next step? Then firewall will check the packet I received. Do we require firewall inspection or not? So what does means firewall inspection? Anyone know about that? What does means firewall inspection? Any idea?
Scanning the IPS and URLs,
Very nice. IPS, URL,
SSL certification,
SSL certification,
and antivirus.
antivirus. Okay, very nice. So absolutely, Sayed, you're right. So that means there is. Okay, let me ask another question. So inspection is like doing the scanning the traffic, virus, URLs, antivirus, malware, worm, whatever we have. But I'm saying I'm not going to do the inspection. Then what is going to happen? Means nothing is going to be checked, right?
Yes.
Okay, so any real-time example, which device basically do not do any inspection? Router does this or not? Switch does this?
No.
Yeah, right. So basically, if you think about the router and switch, this could be based on the layer 2 and layer 3. This is purely layer 3. So any packet is going to reach on these devices. They have only two layer visibility. They can check the MAC, they can check the IP. Same thing here. And they not have the any capability who can understand what content you are sending from that particular packet, and those content basically affected by any virus, any malware, any kind of the certificate is going to be required, any kind of the antivirus is going to be required, any kind of the file is need to be blocked, like block any application need to be allowed. So layer 7 inspection is not possible, content inspection is not possible in case of the router and switch. So they will just do the routing or switching, means they will just take the packet and do out. Nothing more checks is going to happen. Similarly, in the firewalls also, especially in the Palo Alto, when the packet received by the Palo Alto firewall, they check, do I need to do just layer 2 and layer 3 switching, means routing or switching, or I need to perform more actions? So if your inspection is yes, then they will go and check the layer 7 and the content, URL, and other XYZ steps. Whatever it is going to, we'll learn what all steps are required to just do the packet inspection. But if it is showing no, then it will just check the layer 2 and layer 3, and directly from here your packet is going to be sent out from the firewall. Let me show you. So directly from here it will send out packet from the in to out. Nothing else information is going to be checked. This simple definition. Okay. So if I am going to say, do I require inspection? So technically, if you are using the firewall, you require inspection. If you are not going to use the inspection, then why you are looking for the firewall? You just go and use the routers. But
No,
some of them,
excuse me. Mean
yes,
to say, uh, do we need to inspect the local traffic also?
local traffic means you
Yeah,
mean
means internal zones, like one LAN to another LAN.
yes. So by default, Rohan, you're writing something. By default, if you have the LAN A and you have the LAN B, right? And you want to
Yes.
set the traffic, then it is must be inspected. Okay. If you don't
Okay.
want to do inspection, then you have to put some policy in such way, or you have to create in zone in such way, so they will simply process the traffic without any inspection. So might be they will not check any policy. They will just follow the default policy. Even policy will be checked, but that policy will allow any things. So everything is going to be allowed. Okay. So I'll explain. Sayed.
Yes, yes.
Okay. So that means what I was saying means anything is going to be processed by the firewall that must be inspected. If you don't want to do inspection, then that is a different use case. We'll see. I will just want to do layer 2 and layer 3 processing, then my entire layer 7 content all is going to be bypass. So in that scenario, simply packet is going to be out from the ingress to egress interface. Okay.
Okay.
Now moving next, we have the different type of the packet. Till the time, whatever I just explained, this is related to the plain text packet. So we have the two type of the packet. We have the plain text packet, and another scenario, we have the encrypted packet. So in case of the IPsec or SSL VPNs, the packet is always going to be inspected. So let's suppose I receive the packet in a plain text. Then everything is going to be checked. If all is going to fine, then the packet is going to land in the fast path. But let's suppose I have something which is encrypted. Then what is going to happen? How my firewall is going to understand? How my firewall is going to be processed? So every packet, even you are going to do the encryption, they must have some layer 2 and layer 3 headers. If you are not going to put the header, the packet will never travel in the network. So even my original all packet has been encrypted, but your device will going to add some new header. So we have the two method like tunnel mode, transport mode. So we'll see which mode it is going to be encrypted entire header and adding the new header, which mode it is going to just encrypt the payload and they are going to leave the your header open as a original. So we'll see later on, but just think about you receive a packet which have the header. That header was just checked in the while receiving the packet, but at the end of the firewall, when it is going to process in the fast mode, they come to know whatever the packet I received, that this packet is encrypted. So if this packet is encrypted and firewall want to do for further inspection like layer 7, URL, might be data, that is not possible because firewall will never understand what is inside of the encrypted packet. especially in case of the IPsec. So what is going to be happen? The packet must be decrypted with the decryption engine, which is available in the ingress stage only. So the packet is going to be again decrypted with decryption engine, and this encrypted packet is going to convert it in the plain text, right? This is going to be converted in the plain text, and then again this packet is going to send in the ingress stage, and they will again do the same process checked. Means they will do the layer 2, layer 3 extractions. They will check the packet having the fragmentation or not. They will check the errors. They will check the firewall inspection for the new packet. And then the packet will be again going to check whether this packet is encrypted or not. So definitely it is not going to be encrypted because now it has been converted in the plain text to the means encrypted to plain text. So it is going to land in the fast path mode. Okay. Then we have the different scenario from here. Any question, guys, in this particular section till now for the encrypted and unencrypted traffic? Please let me know. All good? Okay, so moving next. Now we have to like check what is going to happen if the packet is going to land in the fast path mode. So now you can see that this is my firewall fast path, and once the packet is going to land in the fast path, we have the two path. One is the fast path, one is the slow path. And if you're going for the any interview, it is going to ask very frequently what is the fast path, what is the slow path, and what is different with the fast path and slow path. And they are also going to ask any packet, it's a new or old packet, when it is received by the ingress stage, which like path they are going to land. Means it is going to land in the slow path or it is going to land in the fast path. So the answer is always going to happen any type of packet, whether it's a new or it's a old. Always the packet is going to land in the fast path, guys. So that's you have to remember. In case of the any scenario, the packet is going to land in the fast path. After landing in fast path, they will decide whether I need to stay in the fast path or I need to go in the slow path. So which condition the packet is going to stay in the fast path and which condition my packet is going to land in the slow path. So let's suppose this is my again a firewall. Okay, this is my firewall. This firewall receive a packet, and this is the very first packet, means first time the packet, new packet received. So once this packet is going to receive, this packet is new. So the firewall is try to check a session, means the packet I receive, do I have any existing setup? If the answer is yes, I have the existing setup, then the firewall is going to like check the session and then it is going to process the packet for the further L2, L4 and the content and application. You can see. So session is going to match, means they have already some concurrent session. They have the cache. So they will further do the processing in the fast path only. They are not going to move again in the slow path. But let's suppose they don't have any session. Then what is going to happen? In that scenario, they have to create first session, means they have to create first connection, and then that connection is going to install back in the fast path. So let me repeat it again, guys, so you can understand. So in any scenario, if I have the new packet and if this packet session is not available in a firewall, okay, that means when the packet is going to receive by the firewall fast path stage, it will check, do I have session? If the answer is no, it will move the packet in the slow path to create a new session. Okay, everyone clear about this fast path to slow path, why it packet is moving? Guys, yes, no, maybe?
Yes, yes.
Clear? All right, so this is the region, means if I don't have any session, I will move in the slow path. Once the packet is going to move in slow path, it is going to check three things. And based on three things, it is going to create a session. Very first thing, it will check the packet I received, do I have routing? The packet I received, do I have NAT policy? Might be applicable, might be not applicable, but it is going to check. If it is not applicable, it is just ignore. But if it is applicable, it is going to be checked. Third thing, most important, do I have the policy or not? This is security policy. If all three condition is going to be available in the slow path, all three condition is going to be available in the slow path, it will create a session. Let me show you. So all three condition is going to meet, means I have the routing, I have the NAT, I have the security policy. Then it will match. If everything align as per your company pre-configured rule or policy, then it will create the session. If it is not going to match as per your created rule and policy, it will simply discard the packet in the slow path stage only. Means, in short summary, let's suppose you have the new packet and network security administration, like administrator, doesn't allow that packet should be processed by the firewall, then it will drop in the slow stage. And if the packet is new and first time user is hitting to the firewall, and network administrator, security administration already created the policy, already created the routing, already created the NAT, then they will check each and everything, validate you, and then they will allow you to go out. Okay, so that's why after checking all these three things, they will create the session, and the session is going to install in this session table. When the same packet is going to land again in the fast path, like suppose Mr. Sayyid want to talk Fahim. Okay. So very first time they want to talk to each other. So they don't have any relation. So firewall will check whether Sayyid and Fahim is eligible to talk or not. If they are eligible, then they are going to create one session based on the slow path. But when the second time Sayyid coming to Fahim, then they have already predefined connections. By using that connection, they will simply go in the fast path and they will check, do I have the session or not? If the session is available, they will simply go and talk to each other. So they will not go in the slow path again to make any connection or validate themselves. So new packet only go in the slow path, always go in the slow path to create the session. Even I'll show you how the slow path and fast path is going to be created in the live when we do the troubleshooting part. Clear? Do you guys understand difference between the slow path and the fast path?
Yes. Yes.
Okay, fair enough.
So just one question, like as you have said, like for the first time itself, it will check for the session is there or not. And if session is not there, it will go to slow path and it will create a session. Okay. And it will the packet will come back to the fast path. Let's say once the session is created, and the session table has been created, like whatever the thing is required, it's already available in the session. Let's say I have changed the policy now, okay, and next time if I'm coming back and the session is already there, so will the packet will transfer or it will get blocked?
You change the policy means what? Change the policy.
Means like, for example, now I've created the policy to allow the packet from A to B, okay. For example, packet should flow from A to B. Okay, so when the packet came, the initial part has been done, and the packet has been
So
came to the
I
fast path.
understand you saying that. Let's suppose you create one policy between these two registers. So
Correct.
policy A created between X source to Y destination, and then
Correct.
after passing that, they create the session, right? Now
Yep.
you delete the policy and the session is there, right?
Yep.
So once you delete the policy, this will simply drop by firewall because session is going to be also wiped out related to that particular policy. It is always automatically going to be removed. If you're not going to
Okay.
have the session timeout, they're going to stay for 360. Let me show you the exact timing. Let me show you. So they have the
30
session
minutes.
timeout. Sorry?
30 minutes, I guess.
Yeah, 30 minutes, right. 3600 seconds. So let me show you. Set up session timeout. Where it is. Operation services. This section it was network. No network now. There one section management. Session timeout. When I forget. There is one section we can see that. Log settings. I just forget it, but I will show you. No one to worry. Okay. There
Okay,
is
okay, no
one we can see the in device section only. It was where something. Yeah, there is a session timeout. I was right. See session, right? So here, if you see TCP session, 3600 seconds. How many minutes is going to happen? 60 minutes?
Yeah.
Yeah, so
60.
this is TCP session timeout. So this is default one, okay? But once you delete the policy, it is going to be deleted. So in session, you have to go in that setup. In session itself, you are going to find the session timeout timer. Okay?
Okay, got it. Thank you.
Welcome. So now we understand, right? So in case of the fast path, the packet is always going to process. They are going to do the different inspection, and after that, they're going to process the packet. Now further check the story. So till now, whatever inspection we have done, basically they are basically layer 2 to layer 4. You can see. What about the layer 7? What about the content? And what about the any traffic which is the HTTPS based traffic? What is going to be happen for that kind of traffic by the Palo Alto Firewall? So let's discuss first about the HTTPS traffic. So 99% case, your traffic is going to come as a HTTPS because you are going to process the web traffic always. You are going to on the internet. So web traffic is always going to process, and based on that, your traffic is going to be processed by the firewall. So that's why you can see the fast path also responsible to do the decryption, means SSL decryption, which we'll understand in the later stage. We have the dedicated module. What is the SSL decryption? Let me show you. So later you understand in detail, in decryption, certificate management, outbound decryption, inbound decryption. So definitely we'll understand these all things. But yes, we have to know what is the SSL decryption and how it is going to look like in the Palo Alto firewall. And in this scenario, fastpath is responsible to the SSL decryption. So what it is going to do that, let's suppose you enable the decryption policy. So any HTTPS traffic is coming. This packet is going to be completely encrypted format. And you want to decrypt, means earlier decryption was the based on the IPsec, but this is the HTTPS packet. So you have to enable the decryption, and based on that decryption, you come to know what is my layer 2 address, what is my layer 3 address, what is my layer 4 address, what is my layer 7, what is the app like URL, what is my data and content, everything you are going to get from that. And after getting those information, you can further check the application user is trying to access that really allow or not. There's two things. The content user is trying to access that really allow or not. If let's suppose this is the HTTP packet, then this decryption is not applicable. So that's why they're talking. After doing the inspection based on the layer 2 to layer 4, they will further check, do I need a decryption or not? If decryption is there, then they will further check, do I need to validate whether this application is particular allow or not, or my content is allowed. Let's suppose you uploading some file, PDF file. That PDF file is very sensitive for their organization. So that should be allowed or not allowed. If it is not allowed, that is blocked by your Palo Alto firewall. So session identification, content identification, that both application and session is going to be inspected, and based on that policy is going to be enforced. If it is aligned, then it is going to process. If it is not aligned with the company policy, that is going to be discarded. All right. Now there is a scenario. Let's suppose for some reason you're trying to access some application, but that application is not recognized by the Palo Alto Firewall. So see, here is the option. It is trying to recognize. If application recognize, then it is go for the content inspection. But some reason you not means firewall is not able to recognize. Then they have the special engine, that is the application identification engine. They will go in that particular section and it will try to check the policy which I am trying to access. Do that really permitted from this particular application? That really going to match, or might be the overridden. Overridden means the policy is bypassed, means the application is going to be bypassed by the certain policy. So that's why if the application is not identified, it will try to check whether this override or not. If that is also not override, then if yes, then simply just go and check the security lookup and process the further packet. But it is not, then it will try to check based on the pattern, their AI and ML based like algorithm to just figure it out what is the actual application for this particular packet. If that is also not going to match or match, then they finally check the security policy and they will check whether this packet is going to allow or deny. If it deny, then packet is going to discard by the application engine. If it is going to allow, then again they will check the content inspection, and then they will do the SSL decryption if it is applicable, and then they will further process packet to go out. So in short, what I'm trying to make a point here means if your application, well-known application is there, and if that is going to be identified by the Palo Alto Firewall, it will process for the content. If it is not going to identify, then it will further put in the application identification, and they will check whether this application which user is trying to send, that's really bypassed by the Palo Alto Firewall, that is the override policy is there or not. You can create the application override policy. I will show what does mean. So if you go in the application, see, there is application override, means you are just bypassing that particular application. You don't want firewall to check that particular policy. That's the application override policy. All right. So that is going to be checked, and based on that, it is going to be further validated. Now, further, what have if like there is no overridden policies configured, then it is going to check the pattern base, and then further they will check the rule whether it's need to be allowed or need to be dropped, and then the packet is going to be further processed. At the last, it is going to check whether the content inspection is applicable or not. So content, that means actual content, whatever email you are writing, whatever data you are sending, that all is going to be part of the content, and that need to be inspected. So they are going to check like every piece of their content, and based on that content, they are going to apply the security profiles. You can see here. So we have the security profiles here: antivirus, anti-spyware, vulnerability, URL filtering, file filtering, wildfire analysis. So a lot of things are here. Based on that, they are going to just access different like kind of the vulnerability, URL filtering, file blocking, DOS protection, and in policy. Let's suppose I am going in the policy, security policy. We are going to basically apply this kind of the content inspections as well. So here you see, if I want to go in the profiles, we have this profiles, and this profile you can just go and apply different kind of the content inspection. Means any file have the spying activity, virus, data leak, file blocking. So we'll test how it is going to look like. So this is responsible to do that all. Okay. And finally, based on the content, whether it needs to be allow or might be the block, they will generate alert as well. So if you create the policy, it will block, and also they will generate the alerts. So all logs are going to be seen in the monitor section. So we have the different threat, URL filtering, data filtering, wildfire summations, global protect, decryptions, user ID, IP tags. So a lot of things are here. So all logs are going to be available in this particular section, and based on that log, you come to know what is happening in my network, what traffic is allowing, what traffic is basically blocking by this particular Palo Alto firewall. Okay. And at the end, the packet is going to be out. And before going to be out, they have to do two things. Means first thing, let's suppose you encrypted this packet, decrypted this packet based on the SSL. So it will re-encrypt again in the content inspection section. So this is the first thing it is going to happen. Now let's suppose your IPsec packet is there. Earlier you just decrypted this packet also. So this is also going to be again re-encrypted your IPsec packet. So this is how two decryption is going to happen throughout your all packet journey from the in to out, and based on that they are going to just further transmit this packet out from this particular firewall. So this is your egress interface. So here decryption is going to be happen again, means encryption is going to be happen based on your decryption, and then Palo Alto firewall is going to send and transmit the packet. So this is the day first about the packet flow, but trust me, this is the very important. And till the session is going to be happen, we have to learn these all section in very detail. Means content inspection, when I configured, I have to explain this section in again. So see, this is the content inspection. Similarly, we have the application identification. So I have to learn again. When we do the troubleshooting, we have to see how the fast path, slow path is going to generate the packet, and how the packet is actually going to look like in the slow path and fast path. And then finally, we'll see the egress and egress, how the packet is going to be transmitted. Any question, guys, in this particular packet flow?
Sir, can you explain one more time this session app identified?
Session app identified.
Yeah.
Which section you're talking?
The fast path.
This one.
Session app.
Okay.
Yeah,
Okay.
yeah.
Session
Only
app.
this part.
Okay. Session app means, like, let me show you. We have a lot of application. Palo, you just go in the internet, Palo Alto Applipedia. If you go in the Palo Alto Applipedia, you are going to find a lot of application. Total 4,976 application available. So these are the well-known application. Even go in the Palo Alto Firewall and go in the object and go to on the application. So you see here 4,605 application, they are already knowing about it. So
Okay.
that means whatever the predefined application available in the Palo Alto Firewall, they are going to identify automatically. You don't have to do anything. Means any application, let's suppose you are accessing WhatsApp. So if WhatsApp application you are accessing and your policy is saying this WhatsApp should be allowed, then you are going to be allowed. If they're saying WhatsApp should be blocked, then they are going to be blocked. Now there is another scenario. They want WhatsApp should be allowed, but voice calling should be blocked. So that is also possible. You can do that. If you're saying WhatsApp should be allowed, but any file transfer from the WhatsApp, means you cannot send a photo from your phone to another phone. So that should be also possible. So in applications, if I want to allow some sub application or block some sub application, that is also possible. Facebook, okay? Facebook have a lot of application. You want to allow some game, video, chat, that is also possible. Whatever you want to allow, whatever you want to block. Clear, guys?
The thing is that if
Yeah.
any application is not there, means in this one, so how can we do that?
So you have to create
It
the
will be
custom application. So let's
okay.
suppose you want to create your own internal application. That application is not available in database. So right now on the
Okay.
4605. So I will show how to create the custom application. But let's suppose I want to create some new application. Okay. So we have to define some category. Let's suppose I'm giving the general internet. It's the internet utilities, technology, something is browser base, parent tab, nothing, risk I can define. There is some advanced and signature also. This might be application is going to work on the port
Actually, in
TCP.
this advanced, we can choose the port also,
Yes, yes.
a
See,
specific port.
I chose TCP port, no? You can see.
Okay. Okay.
So this is how I can do that. So this is the application created. Now you can see the application is 4606. So this is how I can create the custom applications as well if I want. And you can see now, so this application is my internal application, which I created for the Palo Alto. So Palo Alto recognize any communication happening on the 443, they will come to know this is the GUI init application. So they can take some.
Local to this firewall.
Yes, it's not for the all firewall, but this firewall is just like having this application visibility. Okay.
But those 460 will be on the all the firewalls
Yes, the
default.
I will have this only application except this one.
Okay.
Whatever have, they are going to know this much application. Okay. So I wanted to cover one more topic. So we have the another concept that is the single pass architecture, guys. So let me stop this recording and we'll have the quick discussion about that also. So we have the another concept in the module like single pass architecture with the parallel processing. So let's understand what is a single pass architecture with the parallel processing in the Palo Alto Firewall. So trust me, this is the first unique feature available in the Palo Alto Firewall. By using this particular unique feature, this Palo Alto Firewall become the very much popular. And it's defined as a very first firewall as a next generation firewall. And it was having the very great performance at all. So what was happening in this particular single pass with a parallel processing architecture? That means let's suppose in a packet, we have a lot of information, same packet. Let me draw it here. So let's suppose this is the same packet. Let me put here. So this same packet, and in this packet, I have a lot of information. So we have the lot of information here. So again, have the source MAC, destination MAC, source IP address, destination IP address, source port, destination port, right? We have the app, we have the URL, we have some XYZ, and we have the data. That is the payload. So we have a lot of information in this particular packet. So how this parallel processing is going to, there is a two processing. One is a serial processing, one is a parallel processing. So serial processing is that, let's suppose this is the firewall and this firewall receive this packet. So they will first check layer 2 information, then they will check the layer 3 information, then they will check the layer 4, then they will check the layer 7, then they will check the URL, just think about, then they will check some additional, and then finally they will check the payload and data. So one by one, this might be take 1 second, this might be take another 1 second, this might be take another 1 second, 1 second. Just giving the example. This another, this another. So how many is 1, 2, 3, 4, 5, 6, 7. So to send packet out, it take around 7 seconds. Just arbitrary data. You don't have to trust what I'm just explaining right now. It's just example. That much not time is going to take. But just think about while doing the serial processing, this is going to do the packet checks one by one. But let's suppose I want to do the parallel processing. Then how it is going to happen? So my same firewall, I'm just going to put them as same firewall here. Let me, okay. Just give me 1 minute. So just think about, this is my firewall. Okay. This firewall have some kind of the architecture. Okay, this is the one's bigger one. Okay. And this is your same packet. Just think about this packet is going to land it here. So this is your master CPU and they are the small CPU. They are CPU, but a small CPU. So what is going to happen once this packet is going to land in this particular firewall, this interface, this is the Ethernet 0 by 0, and it want to go from the Ethernet 0 by 1. So this is my another interface. So what is going to happen in this scenario? So in this scenario, the packet is received by the master CPU, and this CPU is further for the layer 2, it is sending to this one. Layer 3, it is sending to this one. Layer 4, it is sending to this one. Layer 7, it is sending to this one. And data, it is sending to this one. Means once this packet received by this particular CPU, at the same time, the packet has been share to different CPU, and these all will process the packet exactly with the same time, and they will send the output from CPU to exit interface without any much delay. Let me check why it's, yeah. So they will simply, so I want to draw. Hold on, guys. Okay, some of pen is not working, not responding. So
This packet which is coming to firewall, this has been sent. Mean to say the whole packet is sent to each and every small
no.
processor, or
Only
else
only
it
the
will be divided.
some in like layer 2 processing is going to send to this particular
Okay.
layer 2 information. Layer 3 is going to send to this. Layer 4 is going to send to this. Layer 7 going to send to this, and layer like data is going to send to this. So they all are going to
How?
process and going to be like send at the same time to the egress interface.
Okay. The small CPUs are the virtual inside the main CPU, or else
No, they are the different hardware sitting in the firewall. So
I mean to
this,
say how many CPUs will be there? Small CPUs.
so it totally depend on the firewall models.
Model.
Okay.
Okay. Okay.
So as per your like higher side of the firewalls, they have the more powerful, more CPUs. But if you have the lower side of the firewall, they have the less CPU, like that.
Okay.
Okay. So the packet is going to process at same time, and they are going to save a lot cost. That is known as the parallel processing. Okay. So that's why Palo Alto Network Ingestion Firewall is the based on the unique single pass like the SP3 architecture, which enable high throughput, low latency network, right? And this Palo Alto network solve the performance problem that's plug the today's security infrastructure with the SP3 architecture, which combine two component. Single pass software, that is your PAN OS, and parallel processing hardware is just your RAM, CPU, and ASICs, whatever that have. So by using and leveraging those concepts, they are going to process the entire packet parallelly, and networking is going to happen at the same time. Application is going to process at the same time. Your like layer 2 information is going to process at the same time, and the content is also going to be happen at the same time. So they have the different processor. Let me just show you. So they have the different processor. You can see in this architecture, you will get the more information. So this is the dual CPU, basically the control plane, and this is the dedicated for the control plane. And the because in the Palo Alto, if you see in the particular dashboard also, the most unique feature, they have the dual CPU. Just go in the dashboard, go down. They have the management plane CPU and they have the data plane CPU. So if I talk about the management plane CPU, they have the only one functionality to just manage the firewalls and some kind of the logging and reporting. I want to do that. Data plane CPU, you can see again, they have the like signature match engine, which is known as the security processor, right? Data plane. One is the network processor, one is security processor, one is signature matching processor, different processor. So if any networking related thing, like I want to check the MAC or this processor is responsible. If I want to do the NAT, this processor responsible, this CPU is responsible. If I want to do the SSL, I want to do IPsec, decompressions. This is the dedicated hardware for that. If I want to do any kind of the like security signature matching, this is the dedicated hardware for that. So that's why parallel in the parallel processing, we have the different processor. Those different processor are going to be used for the different actions. So if I just discuss in more detail, let me go here. So let me first show you the examples how this parallel processing is going to look like. So you have seen that this kind of this like a scanning in the might be the railway stations, might be you have seen the airport like that. So these are basically going to be used when we have the large number of people coming to the railway stations, airport, or some kind of other public station, mall like that. So they have the different kind of the baggages packages. Those packages having a further different information inside of that. So let's suppose there are 1,000 people are standing in the queue, and if the manual verification is going to be happen, so probably it is going to take a huge time to just enter this particular channel. So how we can avoid that scenario? So we have to install this machine, and in this machine, what is going to happen? Different sensor is going to be installed in this machine. someone is like scanning your water, someone is scanning your chemicals, someone is scanning your food, someone is scanning your other metals. And once this packet is going to, in particular, this particular machine, all sensors are going to impact at the same time, and they will give the output at the same time. So this is a classic example of the single pass with the parallel processing. Same thing happening in the Palo Alto Firewall. Means the packet is going to be in, the all thing is going to be activated at the same time, and they are going to process the packet at a same time. Okay, guys. So now if I talk about little bit, just quickly, let me see. Just hold on. One more thing I want to discuss. With the slides available or not. No, I believe it is not available in this section. Probably it is. Let me just give me 1 minute, guys. I believe something is not correct. Just give me 1 minute. Let me follow to training. One more slide should be there. Just give me 1 minute. Let me see. Yeah, I found it. So let me show you something. Yeah, this is correct slide. So you see here, right? So I was discussing, right? We have different processing engine, and the packet is going to process parallelly for different actions. So there are three processors. You can say security matching processor, security processor, so security matching processor, and security processor. These are the two different things. You don't have to be confused. And one is a network processor. So we have the control plane CPU, one is the data plane CPU. So data plane CPU is responsible for three functionality. Means they will do the security matching processor, they will do your security processor job and the network processor. But control plane is just such as the management things you want to do that, configuration and some logging and reporting you want to do that. That is the only processor is responsible for that steps. So what is security matching process? Security matching process is something, let's suppose you want to check the vulnerability, virus, antivirus, spyware, means anything related to the next generation feature, IPS IDS, that is the responsible. Security processor is more about the SSL decryption, IPsec, that work is going to taken care by the your security processor. Network processor is something which is just responsible for the any kind of the routing, MAC address switching, MAC lookup, QS, that all is going to happen in the network processor. So that's why you can see in this architecture, we have the different processor, each processor having a different kind of the work allocated, and different hardware if you're going to use in different actions is going to be happen, and different size of the hardware is going to be used for the different use case. Okay, clear? Everyone clear about it?
Yes.
Yes.
Let me know anything else I can add, or we are good for today. Are we good for today?
Yeah, okay. Everything is fine.
Okay, so
Yeah.
let's connect on Saturday. Okay, and we'll continue from here.
One thing,
Yes, please.
can I expect this recording on the portal?
Yes, you'll get by tomorrow because it's a cloud-based recording, so it will take a little time to record, like available on the Zoom cloud. So team will upload by tomorrow. Okay, so you have to give 1 day to us.
All the missed classes are available on that portal,
Yeah,
right?
definitely. Everything like whatever basic foundation we have done discussion, that is also going to be like there. Technically, you missed,
Actually,
right? Yeah, please.
my problem is that by 8:30 I will be in the traveling for the half an hour, so I might miss something. So that I will try to recollect it from the video, and if I have any doubt, I can
Yes, please,
come
please.
back to in the next
Please,
class.
please. Sure, Sayed. Noted.
So this lab access still
Still, you
will
don't
end
have the
what?
lab access, Fahim?
No.
Oh,
No. I just received that portal details now. Still, I haven't logged in.
lab detail. You have lab details here? Not.
No.
Okay, so no, let me ask him. It's suppose there is a holiday, so they about today the joins
Okay.
class. Okay.
Okay. So we'll be
Okay.
connecting on the Saturday, right?
Yes, Saturday we'll connect it.
So
The
Saturday,
same
sir,
time.
are we planning a bit early or on the
So
same
you
time?
guys tell me. Okay, Saturday. You guys tell me. I guys are available with the India time. So there's a slots 4 p.m. IST, 5 p.m. IST, 7 p.m. 6 p.m. IST, which is suitable for you all. This is IST, not ISP.
4 is fine for me. Like
It's good for us.
all are okay.
Anytime.
4 p.m. is the best for me.
4 p.m. fine for everyone.
Yeah, it's okay.
Okay.
But
Yes,
I
sir.
think on the weekend we can stretch the class time.
Yes, definitely. So 4 to 6 will do that. Okay.
Okay.
Okay. So Muthu, you
Indian
also
time.
right?
So 4 p.m.
O-
Okay.
Okay. So why? Because you guys can enjoy the evening time also. So 4 to 6 will do that on the weekend. Okay.
Okay.
Okay. So
Okay.
let's connect on the Saturday 4 p.m. I'll extend the invite. Okay.
And actually,
Sure,
thing is
sure.
that how these classes will be scheduled after this one means it will be daily or else.
No. It is going to happen 3 days only. So it is going to happen Tuesday,
Okay.
Thursday, and Saturday. Tuesday it is 8:30 to like 9:45 or 10. We can do that Tuesday, Thursday, and here we have to 4 to 6 p.m. Okay, just
Okay.
decided. All right,
Or 3 classes per week.
per week. Yeah,
Okay. Good.
we'll cover 5+ hour. No need to worry about that. Okay.
Okay.
All right. So see you guys on the Saturday. Thank you so much. Have a great evening.